Hey everyone. So I wanted to take one last opportunity to kind of go through the ins and outs of word equations. Word equations are probably the most difficult thing we deal with when we're balancing equations because we have to sort of start from scratch. We have to get the formulas for each substance in the equation first, and then we have to balance. So I'm going to kind of walk you through this process as I would present it in class, and hopefully this will give you kind of the guidance that you need. And what I did here is I came up with an equation that covered a few of the more difficult things that you might encounter when you're dealing with word equations. So I'm just going to walk you through step by step. We're going to get all the formulas first, and that's always what we should do here. We should always make sure we have all the correct formulas for each substance before we try to balance. So we're going to start here with fluorine. Now, fluorine is obviously an element on the periodic table, and the first thing you want to check when you have an element by itself in an equation is if that element is one of the 7 diatomic elements that we've talked about in class. And diatomic elements are sort of exactly what they sound like. Di means 2. Atomic obviously refers to atoms, so diatomic elements are elements that will be found in pairs when they're by themselves in an equation. And fluorine happens to be one of those 7 diatomic elements. So whenever we see fluorine just by itself, not part of a compound, we're going to write it as F2. So you can see that I've done that right here. And you notice that I haven't written out the equation yet. I actually didn't have room to fit all of the words on the page, so we're going to write this below once we have all the formulas correct. So, iron 3 chloride is the next one, and you may remember from way back when we first started naming compounds, ionic compounds particularly, that Roman numerals refer to the charge on atoms that can form more than one ion. And in this particular case, we see a Roman numeral of 3. So that means that we have an iron ion with a charge of positive 3. And then, whenever we're trying to figure out the formula for ionic compounds, the crisscross method is always our friend, and the crisscross method uses the charges on each ion. And with these transition metals, the beauty of this is that we're always going to know the charge on the negative ion. Chloride is an ion of chlorine. Chlorine is a halogen, and all of the halogens, when they form ions, have a charge of -1. So, chlorine does happen to be one of those 7 diatomic elements, but when it's part of a compound, that rule doesn't apply. We're going to look at the charges and figure out how many chlorine atoms we have in the compound. So, if I just apply the crisscross method to this, I'm going to have a formula for iron 3 chloride of FeCl3. Okay, so we've got the reactants on the left-hand side of the equation. I'm actually going to go ahead and write those down below so we can organize ourselves. And I'm going to make sure to leave space in front so we can write coefficients. I'm going to try to set this up kind of like we've done in class so far. And so there is the left side of our equation, F2 plus FeCl3. And so now we're going to go to the other side. Chlorine, as we've previously discussed, is here by itself. That's why we didn't change the ending. So it is one of those 7 diatomic elements. So we're going to go ahead and write that as Cl2. And I'm just going to go ahead and bring that down to the bottom as well to save us some time. And now we got to figure out what iron 3 fluoride is going to look like. And since fluorine is also a halogen, we notice that it has the same charge as chlorine, so we notice that we're probably going to have a very similar formula. And so iron 3 fluoride is going to be the combination of our iron 3 ion, which is iron with a charge of positive 3, and then fluorine, the fluoride ion, which has a charge of -1. So we're going to end up with F3. So again, I'm going to go ahead and transfer that down here. So I'm going to try to make a little chart down here. And we're going to keep track of the atoms on the left and the right here. And so we start off with 2 fluorine atoms on the left and 3 on the right. So we have that classic odd-even situation, and we'll talk about how to resolve that in a minute. Then we have 1 iron atom on each side, because the subscript that we see in this formula only applies to chlorine and fluorine respectively. And we can see here that we have 3 chlorine atoms on the left and 2 on the right. And again, when we're first starting out balancing an equation, we have to look at the subscripts, the small numbers to the right of each substance. And we don't have any polyatomic ions here, so we don't have to do anything special with that. So the first thing we're going to do is we're going to try to resolve our issue with fluorine. And one tip when you have an even number of an atom on one side and an odd number on the other is to make the odd number even. And the way we're going to make the odd number even is by doubling it. Here we have 3 as an odd number, so we're going to go ahead and add a coefficient of 2 on the right side in front of FeF3, and that 3 is going to become a 6. So now that we have an even number, we can probably do something about our issue on the other side. So if we want 6 fluorine atoms on the left side, we have to ask ourselves what times 2 gives us 6. And obviously, 3 times 2 equals 6. So we're going to go ahead and put a coefficient of 3 in front of fluorine, and now we have 6 fluorine atoms on the left. So fluorine is balanced. Unless we change it later, we can leave that one alone. So now we've got to do something about iron, because what we've done here is, and I forgot to do this in the previous step, which you should try to keep track of all the changes that you're making when you add coefficients. We have now 2 iron atoms on the right-hand side. So we have to make sure we have 2 iron atoms on the left-hand side. So the way we're going to do this is the same way we did it before. We're going to add a coefficient of 2 right in front of iron 3 chloride on the left. And that's going to give us 2 iron atoms instead of just 1. And it's also going to double the number of chlorine atoms. 2 times 3 gives us 6. So, looks like we have a similar situation as we did on the other side with fluorine. And the way that we're going to resolve this, now that we have even numbers on both sides, is we're going to figure out what times 2 equals 6. You may remember hearing this question before, and the answer is still 3. So we're going to add a coefficient of 3 in front of chlorine, and now we have 6 chlorine atoms, and now we have ourselves a balanced equation. So hopefully this helps to kind of iron out the process of figuring out word equations, getting them from scratch, and I hope it's helpful. So if you have any questions at all, please don't hesitate to reach out, and I hope this is helpful. Thanks.